Hello again. So let's summarize this last video about n-dimensional vector spaces. There's actually very few things that you really need to understand. So the first thing is that what is a vector? So you need to know that a vector is defined by its axioms. And please, you do not need to worry about remembering the axioms or whatever. I'm not going to ask you for the axioms of a vector. The point is that you understand that there is a set of 10 axioms. So for example, one of them is the closure axiom, which says that if you have two vectors u in the vector space V and a vector V in the vector space V, then u plus V is also in the vector space V. That's one of the 10 axioms. Yeah? But anything that fulfills the 10 axioms can be considered a vector, or is considered a vector. Yes? For example, you saw some examples. Vectors in 3 dimensions. Yeah, the arrows that you are used to working with. Or vectors in n dimensions. So this could be useful whenever you are working in a world different to 3 dimensions, which in maths can happen quite often. Or actually any collection of n numbers. They could be real numbers or complex numbers. Any collection of numbers can be considered a vector. For example, an RGB color space, yeah, which represents colors. Or for example, polynomials, which are defined by the coefficients. So a0 plus a1x plus a2x squared. That's a second order polynomial, and it's just a collection of 3 numbers, a0, a1, and a2. So these things are all vectors. Or for example, functions f of x in an interval. Now about this is beautiful. Seeing functions as vectors is a beautiful thing. I really like it, but it's outside of the scope of the syllabus for this module. However, there is an optional video which I will leave in Kits. I will mark it as optional, it's not in the exam, but I explain how is it possible that functions can be vectors. And this will be used in physics a lot in the coming years. Yeah? So if you are curious and want to know about it, go and watch that video. And for example, quantum mechanical states, they are also vectors. You will learn about it next year in quantum mechanics. So all these things are vectors. So they are not just boring geometrical arrows in space. So next is to see. So the next step for you is to look at the next video, which is called the inner product. A warning, this video is a bit more difficult than the previous two because it introduces a new concept or a new way of doing mathematics. So it's basically a way in which I will introduce the operator called the inner product, but instead of telling you how it's done, I will tell you the properties, the axioms that define it. And that's enough to define that operation. So go ahead and look at that video, and later we can do a summary.